Hello and welcome back to Calculus 1 for one last time. I know. This is going to be the part 2 for u-Sub, where we are going to learn how to deal with the definite integrals, and the course is over, right? So last time we said that when we have a problem that we can modify slightly and change into a basic integral, we can use u-Sub to achieve that. And all of our problems were plus c because they were indefinite integrals. Tonight, we're going to take a look, after all of these examples, there we go, what happens with definite integrals with u-Sub. And we can start easy with the example, say 2x minus 1 times x squared minus x plus 6 cubed dx. And now we are going to have limits from -1 to 3, let's say. So we know that we are supposed to compute with these limits, and the first thing we are going to do here is to use u-Sub to integrate, and once we are done with integration, we are going to plug in the limits. Now, you can deal with limits in two different ways. One way is to convert the limits as well to u domain, and the other method is to ignore the limits, and then hopefully you have enough memory in your storage to remember at the end of the problem that you have to compute the limits when you go back to x domain. So we'll see the first method, obviously, because it's faster, but then some of you would like to ignore that anyway and still, do the other way, which is fine. Now, one thing that I'm going to mention here is, if you recall your old integrals, we used to write, I'm going to erase this, integral a to b of f of x dx, where the picture was something like this, and you had your a and b on x-axis, and then you were looking for the area right in there. What's important to understand that a and b are x values, so we can actually have this integral as x1 to x2 and then f of x dx. And what's important is to see that each one of these is always an x variable. So if I am changing my integral into u du, my limits better be u1 and u2 in order for this calculation to work fine. Now, if you don't like that, then you are not going to change limits. You are going to ignore them, and then once you integrate and bring back the x variable, then you will plug the original limits. So whatever. Now let's go and solve this problem. Can anyone suggest what u should be on this in this case?
It's minus x.
Minus x plus 6. Very good. And the du is 2x minus 1 in parentheses times dx. Now we have our peanut, which is this, and we can do the substitution, so we get u cubed du, and that's awesome. So now what's new? New part is you figuring out the limits that you have to place there, and the limits u1 will be computed from x1, so you will be plugging in -1 inside the substitution to calculate the equivalent u1 value. So we have -1 squared minus -1 plus 6. That's 1 plus 1 is 2 plus 8. That's 8. So the bottom limit is no longer -1. The bottom limit becomes 8. And now we compute the upper limit, u2. We plug in 3 everywhere. So 3 squared minus 3 plus 6. That's going to be 9 minus 3 is very good, plus 6. Excellent. So now what I did is I transformed the integral that was solely in terms of x into integral that it's completely in terms of u. And your limits are u1 and u2. That is very important to see that the limits changed as well. Now, when I integrate, I don't have to go back to x because the limits are u, and the u limits can be plugged into u variable and compute the value of the integral. So, the next step is to integrate. That's u to the 4 over 4, and we put the vertical line and just say 8 to 12. So now this is going to be 1/4, 12 to the 4 minus 8 to the 4, and that's going to be equal to a number, right? So we don't have to compute this. That's exact factored answer there. So what we are going to explore tonight is this new piece here, where in addition to your calculations, you also calculate the values for the limits. Let's take a look at another example. What was that? Trig? No problem. Integral cosine squared x sine x dx from pi over 6 to, let's say, pi.
Nick, can I ask you something?
Yeah.
This is out of topic. When you did the graph, what happens when they ask for the area under two graphs?
That we're going to touch briefly upon that later. That's 6.2, section 6.2. Ah, great. So what do we do?
Gotta find a u. Cosine.
Very good. U equals cosine x. And then you should be able to take it from here. You can calculate your sine, then you can calculate u1, u2. Replace everything in. That's all. I'll see it.
He's the Air Force. We gotta get on that. No read. Don't do this. Oh, what was that? It looks so three. Yeah, three. I remember this guy. Square drills. Straight up looking eyes. Straight up red tendons.
Remember that you have to use cosine to change your limits. You cannot have pi limits in the substitution.
What do I feel like? I did not do this right. Oh, because I didn't do it right. Oh, yeah. Yeah, that wheels are back too. Yellow.
It's a video of me.
Oh, that's why.
Yeah, actually. So you have to only you have just you. I wasn't all the way to the whole thing, it's just you.
Okay, let's take a look at this problem together since you... We'll put some spicier examples because obviously this is zero challenge.
Yeah, obviously. Big amount.
du is equal to negative sine x dx, and the new stuff is to figure out the limits. So u1, which is the lower limit, is going to be cosine of pi over 6, which is very good. And then u2 is cosine of pi, which is
-1.
yes, very good. So now we know we need a negative there, so we'll put a sign. Now I have the peanut right there, which is this, and I have negative integral √3/2, -1 on top because that's u2, and then we have cosine squared, which is u squared, and the entire peanut is du. We have transformed the trigonometric integral with pi's in the limits into a polynomial integral with no pi's in the limits, right? Now, can you spot one thing that kind of went backwards? Yes. See, the smaller number is up and the larger number is down, and that's weird. We never had that. It's always 2 to 3 or 2 to 7 or 0 to 5, right? Always the smaller number on the bottom. But we learned the theorem in Calculus 1, which allows you to switch the limits, and then you lose the minus sign in front. If you recall the formula, maybe write it in blood over here, integral a to b of f of x dx is equal to negative integral b to a of f of x dx. So if you want to swap the limits, you have to put in the minus sign, but in this case you would just kill the minus sign that it's already there. So this is equal to positive -1 to √3/2 u squared du. Now we get u cubed over 3 from -1 to √3/2, and then we can kick 1/3 outside and have √3/2 cubed minus -1 cubed. Clean it up a little bit. It's 1/3, and then I have 3 √3 divided by 8, and then we have plus 1. And you can leave it there. That's exact answer. √3 cubed is √3 times √3 times √3. √3 times √3 is 3, and then you have a third √3 stay. 2 cubed is 8. Minus 1 cubed is -1, and then the negative in front gives you plus 1, so all of the calculations hopefully make sense and you are able to get this answer. So that's it. What was that? Okay, we can do the ln problem. Integral of ln to the 6x divided by 2x from e to e cubed and then dx. Go ahead.
What the freaking heck? Dude.
Yeah, definitely.
Yeah. Fuck. He's asking for you. He's asking for you. Let's go.
Hey. So you would be 1 over a here, and we have pull out the 1/2.
Yeah, but so it's just going to be ln, right? Not then ln. So that's going to be 1 over 2x.
Yeah, 1 over a. Just the ln x.
What is that? That's what I think.
Take just the ln x. Then you can 1 over x.
Yes.
Did you make u ln x? Alright, well, I'm going to pick. So then,
ln of e is 1. Yeah, ln of e is 1.
yeah.
So what's the ln of 3? Is that a cube? Oh no! Remember, like we use the ln over the e, put down the that's 1. Oh, is it cubed?
Oh, it's cubed. I thought it was square.
They-
So yeah, no, that makes sense. Yeah, that makes sense.
And that's it.
Because the ln and e would, yeah. ln, so u2, the first one u2 would be 3. Because when you do, so like, for u1, yeah, because ln of e is 1. But the ln of e cubed, would that just be 2? It would be 3 of cubed. So it's a 3 here. It's like ln. Oh, the 3 just goes. Yeah. It's that easy. Yo, my God, we got the cheat code, bro. Hell yeah. So it's 1 and 3. Yeah, it's 1 and 3. Yeah. So is that looking a negative? This is. Wait, you don't have to. No. You have to integrate it now. Got so 3, bring 3 down. Wait, so for how would you, for the integration, I'm trying to,
Don't put it I just figured out the
oh, yeah, actually, yeah, that makes a lot more sense. So then how is that? That's going to be
That's what I'm not.
you just 7 over 7, right? The u are then it's going to be that. You pull out the 1/2. Yeah, that'll be 21. And then go back. Okay, so you draw 1 over 7. Yeah. Then you're just done. Hang on, then you're second. Where the hell did I just do this question? I'm so confused. Where did that page go? Wasn't I just doing this?
Because, add 1, derivative of that.
So is that the final answer? You don't compute things, right? Because you. But if you integrated this in U, wasn't that a separate problem now?
No, because what you got was
It sure is. Minus 7.
and then you said
minus
the limit.
Which is just
When you do the elements,
Did I do this right?
Oh, wait, so what happens to the two after you integrate?
I got way ahead of myself.
So it should be
1/2.
So it would wait, because I took the 2 out. Oh, wait.
1/2, not 2.
Yeah.
Yeah, you can multiply that by 7, right? 'Cause that's
Yeah,
7.
Take out.
But you get you integrate by you, so you can
Yeah, take out a half.
the everyone's
But Nick, where does it go? Like after you
you still keep it.
so it would still be like
Yeah.
that?
1/2. Yeah.
Oh, okay.
Actually, yeah.
So then this,
Do I tell you what happened?
Okay. Keep it.
So that's the
So I guess this would be
now you substitute.
the whole line part.
So I forget that the negative one. You don't do the C anymore.
This isn't right. This can't be right. Because I know you're supposed to.
I think it's that. Wait, you should X something like that.
Now you evaluate.
Oh, wait, no.
Oh.
Yes, number you.
Did you get that number?
It's u to the 6 du. I fucked this part. So yeah, it's supposed to be u to the 6 du. We did the one which integrates. Where did this negative?
no,
Oh, I know the hat. Yeah.
I thought once you
Forgot the hat.
you did
You
all
don't have to combine.
Yeah, right.
You found the limits already.
So 1
Just put 1 and 3
times
you just have, I think
Oh, yeah.
I thought I have 1/2.
Let's see.
Oh, I got you. I got you.
Nick, do I distribute that out once this because this turns to 1 7?
Yeah. Top of
1.
U to the 7th over 7. Wouldn't you turn that into 1 over 6?
Right, but then you have
Well, that's what I'm asking. What do I do with this? Do I multiply that with that?
what I did was I just kept it.
Just multiply the whole thing by half.
I have 1/2 multiplied 3 over 7 to the 7 over 7 and 1 to the 7 which is 1 over 7. I just have the 1/2 out. I think this will.
Oh. Alright. Just want to see the trend. Okay. Alright, yeah, never mind. That makes sense.
Okay.
Yeah, that's.
Yeah.
What's you?
Just added another step.
I don't know.
Lemon X.
What am I?
Can you imagine Lemon X, the new X-Men?
du is?
Legendary. 1 over X?
You'll never guess.
Okay, great. So now, when we solve this integral, we kick 1/2 outside because that's a constant. ln becomes u, so u to the 6, and 1 over x dx becomes du. Now I am going to work out my u1 limit, which is ln of e, which is 1, very good, and then u2 is ln e cubed, which is 3 on top, awesome. This is 1/2 u to the 7 over 7, and we compute from 1 to 3, which is 1 over 14. One over 14, and now in parentheses I just have 3 to the 7 minus 1 to the 7, which is just 1. And that's it. I mean, you can go get the calculator, get the numbers, but yeah. Do we need another example, or this is good enough? One more?
Another one.
Another one, okay.
Drop us a sauce. Do it.
5 chilies. Another vanilla one. Another vanilla one.
Another vanilla, you said?
No.
No?
Vanilla one. Spicy.
Oh, we can introduce. Okay, let's.
It's like store prices, you know what I'm saying? Real spice. Yeah.
Oh, jalapenos. Let's include kill you.
Integral x square root of x minus 1 dx from 2 to 5. Hey, you said spice. I said okay. What is the big problem of this problem?
So you just stack the square.
Yeah, the square root should have a square, x square, right? But it doesn't. Ugh. But still do it the same way, like if it did.
We have to find x. So can you make the exponent of it one found 3? We have to find x. You do the u-Substitution derivate and then find x out of that? Or
Yeah.
only nine?
Let's do it, brother.
Okay, Nick figured it out.
Is it? I think you would be
Yes.
excellent.
Can I just add, multiply the x into this, multiply x to this?
Inside,
Yeah.
if you multiply it inside, unfortunately it won't work because you will get square root of x cubed minus x squared. And you can't integrate this.
So could you make u x minus?
Because this is what you would have.
Either way, you
And there is nothing you can do.
dx equals the u.
So unfortunately we can't do that. But Nick already figured it out. Nick said u equals x minus 1 and then du equals dx. So you have this figured out already and you have this x that it's hanging over here, but you can from here write that x is equal to u plus 1 and plug that in there and the problem is solved.
Bro, that's what bro.
So instead of x, we will write u plus 1. I'll point, I guess, orange like this. Then we are going to have a square root of u and then du at the end. We are going to change our limits. u1 is 2 minus 1, which is 1. And u2 is 5 minus 1, which is 4. How convenient. So now to solve this problem, we have integral 1 to 4, and now you multiply, you get u to the 3/2 plus u to the 1/2 du. So that's when you FOIL, right? Sorry, not FOIL, distribute. U times root u is u to the 3/2 because you have 2 over 2 plus 1 over 2, which is 3/2. Okay, cool. Now we integrate. So integral of u to the 5 over 2 divided by 5 over 2 plus u to 3/2 divided by 3/2 computed from 1 to 4. Now this is going to be 2/5 and you have 4 to 5/2 minus 1 to 5/2 plus 2/3 and then you have 4 to the 3/2 minus 1 to the 3/2. Now this is easy to compute, so let's. Square root of 4 is 2. 2 to the 5th power is 32 minus 1 plus 2/3. Square root of 4 is 2. 2 cubed is 8 minus 1. So this is 31 times 2, 62 over 5 plus 7/14. You want to add this? No problem. common denominator of 15. 3 times 62, 186. Plus, what happened? 5 times 4, 40, 70. Which is 256 divided by 15.
John. 64 Nick. 64 feet. 64 over 5.
Why 64?
Why 62?
Is this 31
Oh,
times 2?
sorry.
The method of integration that you just see now has a name. When you have to do this manipulation, it's called back substitution. When you have to fix it like this. Yes, Chewy? So, no. There we go. Go away.
Epic game fun stuff.
That's right. Shall we? Well, that's good enough, right? We have 5,000 examples over here. So, all right. Bye.
Awesome.